Good morning, everybody. Today we'll be discussing with unit number 4 of Engineering Mechanics, KME 402. The content for this is basically kinetics and kinematics. The topics to be covered in this unit is plane and absolute motion, rotational motion, relative motion, impulse and momentum, and D'Alembert's principle, along with dynamic equilibrium. Dynamic equilibrium will be including motion of a lift, etc., etc. So, starting with the course content, so let us come to the first topic, plane and absolute motion. So, before beginning with plane and absolute motion, there are certain terms associated with this unit, and it is better that we are well conversant with the terms, units, whether they are vector or scalars, etc. So, coming to the first topic, this is kinematics. So, kinematics means that it is the study of motion uh, without uh, without taking into consideration, without considering uh, the reason behind it. So, we do not consider the force or the motive or the prime mover which is uh, giving you this motion. So it only deals with motion, and motion in the sense we are only concerned with velocity, displacement, time, acceleration, etc. We do not take into consideration the forces that are directly or indirectly influencing it to cause. So now the second, if you come into types of motion, we have translatory motion. So translatory motion means that when the motion, it follows a straight line, when the motion is in a straight line. Now the third term that you'll come across is curvilinear motion. In a curvilinear motion, the motion is in a curve. So, in a straight line, if you see the motion, the body moves from point A to B, it has a specified distance. So, we'll be calculating the terms associated with it. In this curvilinear motion, the body may follow this curve where either the curvature or the radius, some parameter will be known to you, which will help you in determining the distance that has been traveled. Fourth is a rotary motion. So, in the case of a rotary motion, we see that the body moves in concentric circles. So, the motion is caused in concentric circles. So, concentric circles means these are circles which have the same center, but they have variable radius. Okay, so, these are different types of motions that we encounter in our day-to-day life. Now, if you come to terms, you'll be coming across a term. This is speed. Now, speed is distance traveled per unit time. This is the distance traveled per unit time. So you will see that the unit is generally meters per second. Now, speed is a vector. Sorry, speed is a scalar. Whereas the same counterpart is velocity. This also has the same units. This also has the same specification that it is distance traveled per unit time, but this is a vector. So you need to understand the difference between speed and velocity. There is nothing except it is a scalar or a vector. A scalar has only magnitude, whereas a vector has magnitude, direction, and sense, everything. So coming to the new terms that you'll come across, one is let us say that it will be uniform velocity. So uniform velocity means the body is moving at a constant velocity over a specified time, or the body travels equal distances in equal times. Now you have variable velocity. So variable velocity means the body travels unequal distances in the same amount of time. So in the case of a variable velocity, the variable may be, it varies at a certain rate, or it may vary according to a specified equation. Now, if you see, you have average velocity. Now, average velocity means that this is the total displacement, or you can say the total distance traveled, and this is the total time taken. So this gives you the average velocity. You have another term that you may come across, that is instantaneous velocity. So instantaneous velocity means this is the velocity at a certain instant of time, and that gives you the velocity at a specific instant. Now the next is acceleration. Acceleration is the rate of change of velocity. Change of velocity. So if you see, this can be written as final velocity minus initial velocity divided by time taken. So this, the unit comes out to be meters per second square, because meter per second is for velocity, and you have again divided by second. This gives you meter per second square. So now coming to the differential aspect of it, we see that velocity, if s denotes displacement, if s denotes displacement, then ds by dt denotes velocity, or represented by v, and dv by dt represents acceleration, denoted by a. This can also be written as d square s by dt square. Okay, so by differentiating and integrating, you can toggle between terms velocity, acceleration, and displacement. You can find out whatever is required at whatever instant. So if you look at the basic equations, how we started all these things. So v minus u by t, where v is, let us say that v is final velocity and u is initial velocity. So v minus u by t is a. So if you rearrange terms, we have v is equal to u plus at. So this is your first equation of motion. Okay. So now, as displacement, if you see, displacement can be written as average velocity into time. Average velocity into time. So average velocity is, displacement is written by s, average velocity is u plus v by 2, final plus initial by 2 multiplied by time. So as v is equal to u plus at. So if you put these values here, you have s is equal to ut plus half at square. So this is your second equation of motion. Now, coming to the third equation of motion, the third equation of motion says that we need to look at v square minus u square is equal to 2as. So to derive it, what we see that as S is equal to V plus U by 2 into T, and V is equal to U plus AT. So from here we can see that T is equal to V minus U by A. So if you put down the value of T in this equation, we have V square minus U square is equal to 2AS. Putting the value of these into uh, this value of T. So S is equal to average velocity multiplied by T. If you put down the value of T from this equation, we will get V square minus U square is equal to 2AS. Now, if the body encounters motion under gravity, if the body undergoes motion under gravity, so motion under gravity means acceleration is defined by G, which is acceleration due to gravity. Is acceleration due to gravity, whose value is given by 9.8 meter per second square. So, if a body moves down, that means it is working along the gravitational force, or it is working along with the gravitational force. So in this case, G is taken as positive. If the body moves up, that means it it is working against the gravitational force. So here G is taken as negative. So these are the situations where we need to manipulate, or we need to vary the value of acceleration due to gravity. Now let us start with certain types of numericals that you may come across in the topics covered till now. So the first type of numerical that generally you encounter is uh, related to motion. So let us see that mm, there is one numerical where we can see that a burglar's car had a start with an acceleration of 2 meters per second square. So a burglar starts with an acceleration of 2 meter per second square. Now the police arrives after 5 seconds. So for him, the time is t. So this is the details related to a burglar. Burglar means a thief. And for a police, t is actually t plus 5. He starts after 5 seconds, and he goes with a constant velocity of 20 meters per second. So the burglar starts from rest at 2 meters per second square. The police comes after 5 seconds, and it starts to chase the burglar with a uniform velocity of 20 meters per second. You are required to find the time taken by police to catch the burglar. So to the time taken to calculate, we need to equate the distances that has been traveled. So if you see for a burglar, the u is 0 because he starts from rest, and acceleration is given as 2 meters per second square. And for police, it is 20 meters per second, a uniform velocity. So the distance traveled for him, for the police, will be S will be equal to uh, U UT. S will be equal to VT. So this is 20 into T. So this is 20 into T plus 5. because he starts after 5 seconds. And for the burglar, or you, t plus 5, and mm, for the burglar it will be s is equal to ut plus half at square. So u is 0. So he will only be having half at square. So s is equal to half into 2 into t square. So if you equate them, you have 20 into t plus 5 is equal to half into 2t square. You get the value of t, that is 5 seconds. So at t is equal to 5 seconds, the police will overtake the burglar and he can be found out. So at t is equal to 5, you need to find out s. So you can put it in any of the equations. You can find out the distance traveled before the thief is actually caught. So this is one type of numerical that you may come across. The second is uh, two trains, let us say two trains, there are train A leave the station on train A and train B leave the station on parallel lines. The train A starts with a uniform acceleration. That means A is 0.2 meters per second square and attains a speed of 45 kilometer per hour. Attains a speed of 45 kilometer, and after this speed is constant. Now train B leaves 1 minute later. It leaves 1 minute later with a uniform acceleration of 0.4 meters per second square, and it attains a maximum speed of 72 kilometer per hour, and then it remains constant. Okay. You are supposed to find out when will train B overtake train A. Okay. So to find out this, let us first convert them into similar units. This is second, this is meter, this is kilometer per hour. So the first thing that you have to keep in mind is you need to convert them into similar units. So to convert them into similar units, train A. Let us see the details of train A. Train A is running at 45 kilometer per hour at constant speed. So if you resolve them, so this is 45 into 1000 meters divided by 3600 seconds. So this comes out to be 12.5 meters per second. Now similarly for train B, this is 72 kilometer per hour. So this comes out to be 20 meters per second. Now for train A, uh, if you see train A, V is given by for A. V is equal to U plus AT. So why we need to find out, this is the time until which the train will be accelerating, because there are two motions of the train. One, it is at constant acceleration. Once it reaches 45 kilometer per hour, then only the speed is constant. So the accelerating time you need to find out first. So to find out the accelerating time, it is 12.5 is equal to 0 plus 0.2 time of training. So train A accelerating time is 62.5 second. So the accelerating distance during acceleration, this train will also travel some distance. So S is equal to ut plus half at square. So you know the value of t. This is 62.5 second. U is 0 and t is equal to 62.5. A is 0.2. So you get S is equal to 390.6 meters. Now, if you similarly take the instance for train B, so here also you initially it starts from 0. The acceleration is it accelerates till it achieves a constant velocity of 20 meters per second. So this is 0 plus zero point 0.4 into TB. So from here you get TB is equal to 50 seconds. So the train will travel a certain distance in this 50 seconds. So again S is equal to 0 into T plus half into zero point 0.4 into 50 square, half 80 square. So the distance traveled during these 50 seconds comes out to be 500 meters. Now you can see that these two are, if you see the distance, final distance traveled after this acceleration has stopped. So train A travels a distance of 390.6 plus 12.5 and T minus 62.5. Why this 62.5? Because until 62.5, it is in accelerating mode. Once it has crossed 62.5, it attains a constant velocity for which the relationships are given. Now, this will be equal to the distance traveled by 50, sorry, it is 500. This is 500 meters plus. This is uh, 12.5. So this is 20 meters per second multiplied by T minus 110. Why this 110? Because until 50 seconds, it is accelerating, and after 50 seconds, it is actually running late by 1 minute. So 60 seconds for that and 50 seconds for here. If you equate both of them, you get the value of T as 174.58 seconds. So at a time of 175, approximately 175 seconds, train B will be able to overtake train A. So in this problem, again, if you want to find out the distance travel before actually the trains overtake each other, so you can put this 174.58 in any of the equations. You will get the distance traveled by the trains before they actually overtake each other. Now, there is another type of problem that you may encounter is, let us say that a ball is dropped from a certain height. So let us say that this is a floor and this is the top of some building. And if the ball is dropped uh, at a height from here, and at the same time a ball is again thrown upwards from here. So if this is ball A and this is ball E, and the total distance, let us say it is 100 meters. So you are required to find out the time or the distance at which they actually intersect each other. So if you look at this ball, the motion of ball A, so this is given by S is equal to ut plus half ut plus half at square. So if it is coming down, A is actually equal to 9.81 positive. So the distance travel, let us say that from the top, that it travels a distance h. So h is equal to u is 0 because it is initially dropped from 0 velocity. So this is half into 9.81 t square. Now at the same time, if a ball is thrown up with a certain velocity, let us say it is thrown up at velocity of 20 meters per second. So the equation of motion becomes 20 into t plus half uh, gt square. So this half is actually minus, as it is working against gravity. So this is minus half into 9.81 and t square. Now the distance traveled by h before they actually meet is 100 minus h. So if you see, this is equation number 2 and this is equation number 1. If you add equation number 1 and 2, add 1 and 2, what will you get? H will be eliminated and you can find out the value of t. This value of t, when you calculate, uh, you can put it in any of the equations. You can find out the distance traveled before the balls they actually intersect or meet each other. So these are some problems. You can follow any book and you can see other different types of problems that you can encounter in this chapter. Now, the next type of problem is, let us say that S is given by 12t plus 3t square minus 2t cube. You are asked that what is the velocity and acceleration at start, and let us say that acceleration when velocity is zero. Acceleration when velocity is zero. So these two things are, suppose they are asked. So if S is equal to 12t plus 3t square, so ds by dt is v. So if you differentiate it once, you have 12 plus 60 minus 60 square. And again, d square s by dt square is acceleration, and this is 6 minus 12t. Now coming to the first, velocity and acceleration at start. So to find this, velocity and acceleration at start means that at t is equal to 0. So put t is equal to 0 here. Put t is equal to 0 in these two equations. You can find out the two answers. So if you put t is equal to 0 here, the velocity comes out to be 12 meters per second and acceleration comes out to be 6 meters per second square. So this is one half of the problem. Second half says that acceleration when velocity is 0. So velocity is, you can say that given by 12, it is 12 plus 60 minus 60 square. Okay. So velocity is 0. You put this equal to 0, you will get the value of t. The value of t comes out to be at 2 seconds. So means at t is equal to 2, you will have the velocity 0. Put this t is equal to 2 in the acceleration equation. So you get acceleration is equal to 18 minus 18 meter per second square. So this is one type of problem where you need to differentiate or integrate from one point to another and calculate the various parameters. Now the next type of problem, let us see one more. Let us say that the acceleration of some vehicle is given by 10 divided by v plus 1 meters per second square, where v is the uh, velocity. Now you are required to find the distance, find distance. So find distance means you need to find out s when velocity is 35 kilometer per hour. Okay. So you can, if you see A is given by, so A is equal to dv by dt. So if you write this here in another terms, now or dv by dt can also be written as dv by ds multiplied by ds by dt, as ds by dt is equal to velocity So acceleration can be written as v into dv by ds. Now this is equal to 10 into v plus 1. So you have v into v plus 1 into dv is equal to 10 ds. So if you integrate both sides, integrating both sides, you integrate both sides, what do you get? V cube by 3 plus v square by 2 is equal to 10s plus c. Now, the c is constant of integration at s is equal to 0. At s is equal to 0, you have v is equal to 0. So if you put this, you get c is equal to 0. So you need to find out the constant of integration also. So the final equation comes down to v cube. Let us further shorten it up. It comes out to be 2v cube plus 3v square is equal to 60 s. Okay. Now v is given as 35 kilometer per hour. So if you convert this into meters per second, you have 9.72 meters per second. So if you put in this equation, put v is equal to 9.72. So you have s is equal to 35.5, sorry, 35.35 meters. This is the distance traveled for this problem. So this is another way by integration. If you look at the previous problem, the variables were found out by differentiating the parametric equation. Whereas if you look at this situation, the variables are found out by integrating the parametric equation, and you can find out the various unknowns. So these are the various terms that you need to come across. Now let us take into account another type of problem. This is probably the easiest one, where you will be calculating various parameters from the graph itself. So to calculate it, let us say that we have a velocity time graph given. This is velocity, this is time. So if you look at the graph, this is the velocity time graph given. This is something like this. This is the velocity time graph given, and this is 10, this is 20, this is 20, and this is 30. This is the motion of a velocity, and you need to calculate. The problem says that calculate the total distance traveled. You need to find out the total distance traveled. Okay. So if you see, uh, it is a velocity time graph. So distance traveled is area under the graph, is actually area under the curve. So area under the curve means this has to be found out by integration. Integration gives you one method of determination of area under the curve. So integration of velocity actually gives you the displacement. Okay, so because if you see, velocity is ds by dt. So if you integrate both sides, you get the value of distance traveled. So for to calculate the distance traveled, velocity time graph will be given. If it is an acceleration time graph, you can calculate the velocity by integrating it once. So area under the curve or integration both mean the same thing. Okay, so to find out the area under the curve, you need to simplify. This is a triangle, this is a trapezium, and you can find out the area. So, sorry, so if you find out the total area, so S for this it is half into base is 10 and this is 20. And this is the area of this triangular portion. Now, the area of this trapezium is sum of uh, two sides multiplied by the base. So this is again half into the sum of two sides is 20 plus 30 into the base is of 10. So the sum of two areas gives you the total distance traveled. So S, this is 100 plus this is 250. So this comes out to be 350 meters. This is the total distance traveled, and these types of problems, they are found out from graphs which are predefined or stated in the problem. And by looking at the graph, you can say what all you can find out, because actually you can, by looking at the graph, you can actually find out the area only. So area means if it is a velocity time graph, you can find out displacement, because area, determination of area means integration. If it is an acceleration time graph, you can find out the velocity at a certain speed. So this is all about related to linear motion. Okay.